So what he's essentially asking is, how to train a model using a cloud, right? And you want to use a train model to the prediction on Raspberry Pi. Okay, this is very easily done.
Trained, we have to
bring that model here. Absolutely, that is done. Okay, let's just revisit what we did yesterday for a few minutes. Okay, we started with machine learning. Then what is machine learning? Supervised, unsupervised. Supervised has two categories, right? Your regression and classification, right? For regression, there are the one algorithm we visited was a simple linear regression, which is predicting a straight line. Then we saw how polynomial features can be used. Okay, how polynomial features can be used. Okay, then we try to use make pipeline, and we had a transformer and an estimator, right? Let me show that code. Like in this case, right, we had a transformer and an estimator, right? We wanted to predict which transformer is giving you good results, as in this case. So you can see a line with degree 1, this is a straight line, a line with degree 2, a line with degree 3, a line with degree 5 is here. Okay, we calculated score also, right? R2 score and or RMSE to compute the loss, right? And using that we found out which one is doing good, doing better, right? So how it all started, generally what will you do? You'll create a pipeline. Okay, today I'll do some projects using pipeline and all that, right? Take some real data, some real stuff, how to solve it using pipeline. But you essentially have a have few transformers, not necessarily one. You can have few transformers. Output of one becomes input to another guy, output of another guy becomes input to another guy. You can have a series of transformers. You can keep changing the estimators also. As of now, in this case, as of now, yeah, hello. So you can keep changing estimators also here. Okay, what we saw is we just used one estimator last time, right? We can write a loop, a list of data and loop, and for each transformer we can try different estimators. Okay, so what will
Avantik?
Yeah,
Avantik, this is Sunil. I had a question. If you're in the flow, I will put my question later to them.
So that's fine. I mean, if it is regarding yesterday, so this is the time what we are discussing is mostly what happened yesterday. Okay.
Yeah. What I understood here is that the transformer is just generate a model, and the estimator is to predict the result, right?
You can say transformer is for converting the data to something you want to feed in to the estimate. Okay, just to recollect, what we had is one dimensional. I mean, we had two columns of data, right? But if you have a polynomial degree of 3, it converted all the possibilities of it. Then this became input to the estimator. So generally, the general meaning of transformer is for transforming data from one format to another.
Okay.
Degree conversion,
degree string. Yesterday during the end of the session we saw string conversion as well, right? So that is also transformer.
Okay.
So we have
just use the prediction for estimated that one.
Estimator, linear regression, whatever we use, right? That was estimator.
Regression is whatever we use for the algorithms.
Right.
Estimator is like algorithms what we use.
Algorithm what we use. So what we'll do today, we'll learn. I mean, we see. Frankly speaking, you have to be very good with this pipeline concept. Okay, whatever algorithms are, those are very organic. I mean, you use it, you learn it. That is the way. But how do you apply it? That is using pipeline. Okay, so that you can write some code which executes and gives you results. That is the end goal. Because if you don't see, output, if you don't start solving the problem, feeling the fun out of it, you lose the interest of learning machine learning. So that is why it is very important. Okay, to see the output. Okay, so by the end of today's class, I'll give some assignments after today's class, so that in the next whole week you should be able to try out few things, get some result. 50% accuracy, that's fine. 40% accuracy, that's fine. But get some results. That is the objective. Okay, I'll just revisit this part, which I would say is very important part of the entire ecosystem. Okay, what you see here is what you see here is the houses of house size, right? This is the equation that we assume that we are predicted -40 and 25, and what we got at the end is y. So given X, this is your data matrix. Okay, this is your parameters, this is your prediction. So given data matrix and prediction, you should be able to find the parameters. If it is degree square, this is one degree, right? If you are having a polynomial degree of power 2, it will have one more column with same number of features, one feature. If you have more number of features, okay, your number of columns get increased here. If number of columns gets increased here, number of parameters in this guy in parameters matrix vector, okay, also gets increased here. Okay, and this is what we eventually have to find out. Okay, see, this is a case, right? So if you have one feature and all possibilities of parameters, right, that is what, right, it has to find which ones. You will get different output for each column that you see here. For each column that you see here, you have to find the cost. What was cost of this is one line, right? Prediction per one line. What is the cost of that? 1 by 2m sigma of 1 to I was 1 to m, and h theta xi minus y square. Right? This was your cost function. Okay, you'll find cost function for this and see which one is doing better to you.
At least first win.
So the formula we need to apply here and
No, you don't have to do. All these things are happening internally by
manually if you want to verify
you can do it.
cross verify means so that coming results correctly, we need to manually need to do that formula.
Cross verify you don't need to do, because that is what it is doing internally for you. For cross validation, I mean, see, there are two things. Understand two things here. One is, for a given model, for a given degree, you have to find which is the best values of theta. This is what is done using gradient descent. Understood? For a particular degree of model, you have to find best coefficients. This is achieved using gradient descent. But how do you compare it across different models? Yeah, this line is very important. Okay, using gradient descent, right? Using this method, right? What you are trying to find out is which is the best combination of thetas for which you are getting the least cost. Okay, and how do you find which is the best degree polynomial to do so? Two level of competitions are actually 3 level and 4 level will be there competition. Okay, first is for a given degree, for a given model. Like when you say straight line model, that is one model, one type of model. When you say degree 2 polynomial model, that is one type of model. For a given degree, for a given model, if you have to find the best combination of theta, this is what gradient descent does. Next stage is you have to find which is the best degree. Okay, best way, which is the best model here, best degree polynomial to do it. Then your pipeline and finding accuracy, this sort of things we used to compare across this. Now then you have to find out, okay, degree is fine, model is fine. Linear regression, or there is something known as random forest regressor. some other regression algorithm, which is better, right? So you can see multiple hierarchies here. Okay, then for a particular model, when you find out, okay, this guy is better, then you try to change some parameters, initial parameters. That is what hyperparameter tuning is. Okay, so you have things competing with each other at different levels. Understood? That I can visualize this thing, right? That is happening. We have to find out. Now we did the very basic stuff, competing against models. Next would be, okay, competing against estimators. Now only transformer competition is happening, right? Right. Next stage would be competition against estimator. Okay, then competition against transformer and estimator. Right. So that's what I'm saying. So that is why the number of possibilities are a little more, right? That is where your experience comes into picture. The more you solve problem, you'll get the intuition. You'll get the idea, okay, this sort of problem I need to solve this way. Definitely few things I'll be discussing, but a lot of these things come as you solve more problems.
Finally, comes with accuracy. We can say with accuracy only which
Accuracy.
is the best estimator.
Absolutely.
Once we finalize the model, with one parameter we might have used it. So we have finalized this model is fine, and it goes to estimator and we do that. So then degrees, which one is the degree is the best one you are choosing. When you change again the parameters, the same model will work as we were expecting, or it might again it will change.
Same model, same parameter should give you.
No, not the same parameter. I'll increase the parameter.
No, you'll get different output.
Okay. Again, we have to check it, right? Which model again?
Yeah, of course. Okay, so that's why it is entirely an iterative process. There is, I mean, that's why environment is good for doing it. You can do some things repeatedly again and again. Okay, it's not like regular, code that we used to write in Java or in where you write the code and it is done. It is like, getting the final thing maybe, continuously to try few things out.
But yesterday when you're importing linear regression, and when you increase the polynomials between the two, it's not anymore linear, right? It's like an exponential something else. Then why it is a linear regression?
So don't worry about the term. Actually, linear regression means there is a linear relationship between the data. What is linear relationship between the data? That means if one is increasing, other will also increase, or one is decreasing, other will also decrease. So it will not happen that one is increasing, other will increase and decrease and increase and decrease. That is not supposed to happen. That is non-linear data. Okay, linear regression basically means there is a linear relationship between the data. If one increases, other increases. So the regression, whatever linear regression, logistic regression is good for such linearly separable data. I repeat this term. Okay, when you say linear regression, it means it is meant for data which is linear in nature, which has relationship of linearity in nature. What is relationship of linearity in nature? Which one increases, other also increases, one decreases, other also decreases. So there is a relationship. It's not sinusoidal. If this guy increases, this guy sometimes increases, sometimes decreases. That is not in a general trend. Okay, so linear regression is good for, I mean, I'm not saying overall, not even one exception should be there, but in general, it is good for linearly separable data. Understood what is linearly separable?
So then in that case, the data
linear, I mean, the reason why, this is a very regular question. Linear, linear line, we use both of a straight line. As of now, right, based on our school, college, and whatever, we always understand linear as a straight line. But here, linear means linearly separable data.
How do we determine like when to use the linear?
So that is what actually discuss these things in this thing, random forest tree. Those are non-linearly separable algorithms. Okay.
Binary search.
Binary search. So that's a decision tree actually. So how it is important, right? How to know if it is linear? So you do linear regression and you realize it's not giving me good results. Then you might have an intuition. Maybe this data is non-linear in nature. You apply random forest. You see it is you are giving good results. So you think, this is non-linear data. So all your neural networks, random forest, all these things will work well there.
After applying, we'll come to know whether it's linear or non-linear.
Even before you can know it. Like for example, if you have some knowledge about the data, right? You can plot some relationship graphs, charts, and all that. You can see, by just increasing Q. If you see correlation of it,
demand and supply.
Demand and supply is one example. Then you see correlation between the data, right? If you see correlation between the data, you see there is no really good correlation. Right? Then you can think, okay, maybe if I try to apply non-linear data, get better results. Nonlinear algorithms.
Correlation means it's
In one increasing, other decreasing, or increase, that sort of relationship. Okay. So don't worry. I mean, at this point, we just had one class of it, and when we see more nonlinear algorithms, we'll try to find out which one is better, and that is where your scikit, this pipeline is very important, right? It can tell you, a lot. It is not only for prediction. You are using machine learning algorithms for understanding data as well, right? You can later on you'll see you'll be using some algorithms to find which are the important features. Okay, so let's proceed. Okay. So I'll again touch upon a little bit of math, similar type of maths in logistic regression. Okay, so there will be a kind of a revision of it. Okay, and so just keep in mind, you have three important. One is a cost function you have to keep in mind. One is gradient descent. What is gradient descent? Gradient descent means you will just remember that remember by diagrams that U graph we plotted, right? What we have to do, we have to find a possible straight line, right, whose slope is equal to 0. So d by dx of that curve at which whatever point it is 0, that is that result. Just keep that in mind. Gradient descent is used to find the values of theta 0, theta 1 for which the cost is least. Just keep these checkpoints in your mind. You will remember everything else. Okay. So now, okay. So let me do a little bit more feature engineering so that I can take up some more data and show it when we are doing it. Right. So you can see here, this is dictionary of data. Each row is a dictionary here. Okay, this is a list of dictionaries. Okay, now what we want to do, we want to see what you can see. This is number here, first column. Second column is number here, but third and fourth column are not numbers here. We basically want to convert them into numbers. Okay, so what will we do is, okay, what will we do is we will try to use dict vectorizer for this. Okay, so there are two things. Sparse is equal to false. Any idea what is sparse matrix? You remember sparse matrix was something like a matrix which has very less data in it. A lot of zeros are there. That is known as sparse matrix. Dense matrix is something which is which is not sparse. I mean, it is completely filled with data. That is a dense matrix. Right? Sparse matrix is less amount of data. No, generally sparse matrix will be huge size. Right? Only some data will be filled up there. So there is another optimized way of storing the data there. Okay. So what you're doing here, you are actually creating a dict vectorizer. You are basically initializing this. Sparse is equal to fault, data type is equal to int. Right. Then what you're doing here, fit transform data you are passing. On doing so,
Avanti, can you please print that vector, the output of the
this is the empty as of now, nothing.
You're just creating the object. Okay.
Okay. This line will create the stuff. Fit transform will create the data for you.
Okay.
Yeah. So now when you do fit transform data, it will choose all the all the options, all the possibilities, and convert them into numbers. You can see here what it did basically. You are using dict vectorizer, right? Okay, and you are passing the entire data frame. That is what we are doing yesterday. You are passing the entire data frame. What it did was, see neighborhood column. Okay, how many possibilities are there? 3 possibilities, right?
Yeah.
So what it does here, it will create 3 columns for you. This is okay, 3 column. You can see here. Okay, and okay, 3 column for you, and wherever like first guy has queen tan is equal to 1, right? So column corresponding to queen any will be set to 1. Okay, if I do this data trans, if you see my data is like this, and if you want to know which column is what, you have to use the name feature names, right? You can see here first is lower column, so whichever this is lower column, so you can see second data must have lower. Okay? Second data has lower. All the 3 are upper, all the different one, right? So you can see this. You understood it? Why these 3 columns are present? Middle, lower, middle, upper, right? First column is lower, next column is middle, next column is upper. Yeah. Right? See the next guy, neighborhood. 3 options are there. 1, 2, 3. Sorry, 1, 2, 3. Fairmount, Queen Anne, Wellingford. So whichever is set, the value is set to 1, 0. Then this is price. Then this is rooms. Right?
When you see the it was price and it was lost.
Order does not matter. Order does not matter. Column order really does not matter. Okay. And of course, you change it and all that.
When you put the data,
Huh?
data can show it.
Yeah, data is in this format. We can have it in data frame also. I'll just show that.
So this is a sparse matrix, is it?
This one, the output is not sparse because we have given sparse is equal to false.
But you said sparse will have a lot of data.
Because there is small data and we want to see it actually. Sparse matrix, it will be difficult to see and understand it.
This is dense matrix.
This is dense matrix. Okay, sparse matrix will show it if you want. Okay, so let me create a just checking for some data. Titanic data was useful, isn't it?
Train.
Income adult. This is also good data.
But even if we give this sparse equal to the same data will come, right? It's not the information is there and so forth.
In this case, the sparse will be a little compressed actually. It is not human readable. See, sparse matrix means, you have a lot of empty void spaces in it. So how it will store data is different from how it stores it in matrix. Got it, right? So it will try to minimize the space wastage.
So instead of 0, it will be like
It will be stored in a different format. We won't be able to read and understand it easily.
it's not used in machine learning.
No, it is used in machine learning, but we won't be able to read it. In data frames, your code will read it. Okay, so we won't be able to read it. Okay, so let me show one thing. cd dot read CSV. I'm scared doing it because it has huge number of columns. See this on data first. We have this HR data. Okay, so let me first create a so we know, right? We remember what is the HR data. So let me dump it. Right, you have 2 columns, which is string here, right? So what we would do is we will fit transform. Same thing. Yeah, but there was one way to do it actually. Just Okay, so yeah, okay. I just let's see one more thing. Just go to that. Okay, so similarly, okay, this is possible. I mean, you do it and it will directly convert it into this format. Just okay. The next thing is if you have some sentences like this. This is first one was converting them into these columns. Okay, one hot vector. I mean this individual columns. The next thing is what you have is called text features. Okay, you can see this one sentence here, this one sentence here, this one sentence here, right? We have to, like, this is your review comments, right? Right, multiple words. Now we will use something known as count vectorizer. Dict vectorizer, right? This is count vectorizer. What will count vectorizer do? Basically, you can see it will take sample data. Okay, and in this case it is, I mean, we didn't tell it to generate non-sparse matrix, so it is generating a sparse matrix. Okay, we cannot, it's compressed, you can see here. We will not be able to make much sense out of it. Okay, so if you do fit transform, this is the sample data, this is the count vectorizer object, this is we are doing a fit transform to sample data, and if you see the contents of it, okay, and we, oh yeah, that is how we are doing it.
It's not printed anything.
Yeah, I don't print it, is compressed, right? Okay, then you know, we want to see the contents of it, so then to print the content of it, you do x.toArray. Okay, then the column names you pass. Okay, then it will create a data frame, it will show it like this. You can see here, evil in the first data, evil is twice, so evil will come 2 times, off is 1 time, right? So you can see this data here. Understood? Okay, yeah, and here you can see that, you know, off word is not important, right? But it's still coming. So if you want to get rid of that, you have something known as stop words. Stop words English. If I do this, and if I do this, and if I do this, now see, off will not come. All the unimportant words will automatically not come. Okay, you don't have to go there and filter it manually. It has the list. If you're mentioning here English, right, it knows what are the prepositions, all those things in English words.
Something particularly if you wanna avoid some particular word, if you wanna avoid it.
Right.
So you
can pass your set of list also, right? Or if you want some words to be only present there, you can inside count vectorizer or any such vectorizer, right? In fact, in above also, in dict vectorizer, you can pass here the words that you are interested in, right? In count vectorizer, then you have tf-idf, another vectorizer. So we'll use this techniques in solving. Just as of now, just understand, given a particular, you know, data, we can convert it into data frame. Once we have it in data frame, we can merge it with the existing data frame, isn't it? Okay, that is what I'm supposed to do below. Okay, just one more thing, that is tf-idf. It's not here. So tf-idf is another type of vectorizer. Okay.
Use count vectorizer. The views analysis, they will use count vectorizer.
In analysis.
They will take
they will use count vector. They will use tf-idf actually, which I'm about to show now. So tf-idf is kind of you know, more. This is the one. Okay, you can see here what we are doing here. We are using from feature extraction test tf-idf vectorizer. What is concept of TF-IDF? See, suppose, remember, understand this step. Suppose we have, what is the term here? Corpus, first thing. What is corpus? Collection of all the documents. You can say collection of all reviews is known as corpus. Everybody's reviews as of now. That is the entire lot. That is known as corpus. Then when you have collection of all these things, that is known as corpus. Next thing is each document will be one review. Understood this point? Okay. One review. Or to simplify it, let's take Wikipedia. Collection of all the documents is known as okay. Collection of all the documents, all the Wikipedia documents is known as corpus. Okay. Then each Wikipedia page is known as each Wikipedia is known as document. Now tell me, like article like Mahatma Gandhi, for example. Okay. Do you think Mahatma Gandhi will be an important word?
Yes.
Right. If a document has Mahatma Gandhi, politics, 1940 to 1947, all these related events, right? Top, then you can say this is the summary of it, right? Okay. Now, how will the word of will be repeated more number of times in the entire corpus, or Mahatma Gandhi will be repeated more number of times?
He will be.
Huh? No. Of. In the entire corpus, of will be more repeated, right? But of is not important. So how do you find importance here is, if a word is appearing more, the frequency of a word appearing in one document is more compared to frequency of that word in the entire corpus, then you said this word is important for this document. Understood? Huh? Let me show it with an example. Like you see this example here, right? Problem of evil, queen of evil, horizon of problem, some evil stuff is there. Okay. So when I do, this guy, TF-IDF vectorizer, you can, after it is calculated, the first line had, the first word is evil, first column, right? So you can see the second line had multiple times evil, 3 times evil, isn't it? 1, 2, 3. So evil word is realized to be much more of importance here, right? Evil word is there in other 2 documents also, but lesser number of times. So less important. Here the importance will be between 0 and 1.
So whatever the weightage is given for each row, it should be 1, but here it seems to be more than 1.
No, sum of the weightage is not 1. Sum of the weightage is not 1. For each row, what you are asking is sum of the weightage should be 1, right? No, not that. Each word's weightage is between 0 and 1.
But there should be a comparison, right? Relatively.
Huh? No. Here, comparison, of course, is there. If somebody is like 0.87 is more than 0.49. In the second row, you can see 0.87 is more than 0.49. So this guy is definitely, evil is definitely more important word here compared to this. Huh? It is here.
Sample.
Oh, sample. Oh, okay. This is one line, this is one line, this is one line. You can see horizon is not appearing in any of them, right?
Yes.
So if you see second column, you can see it's a very high value, right? So that this is very important. Like, so if somebody is writing some unique, in the review comment, somebody is writing some unique different words, or there is some document, this is used in document classification. You have a document, you have to identify what are the important words in this document compared to the entire corpus, right? So if you do this exercise, you'll realize that if you do David Beckham's analysis, you'll find football, his name, you'll make out 10 most important words out. That is actually good enough to give you summary. It is used in tag identification. In many news article, you will see tags, right? Hashtag tags, right? It is used there. Like in Times of India, I don't know they're using it, but a lot of many other websites, they find important words from the entire document using this technique.
So as you said, when the wiki page many times, we have to suppose that preposition first and then.
No, you don't. You can do that, but it will. You have to suppose those prepositions first. Like you will mention stop words is equal to English here, so that all the unnecessary words get omitted. and then
Each word is way. Line number 31. Output 31. So each row is representing each word.
Each row is representing each.
No, that weightage, whatever is that, 60.61.78.
This one, right?
Yeah.
This is weightage of evil word.
No. For each word, it is having a weightage.
Right.
So when there is an evil, is it just comparing the particular row or is it compared with the every row? For example, I'm checking for horizon.
So there are three evil, right, in the second line, second row. But we have weightage for point.
We have, yeah. You can see the mapping here. Evil is this column. Horizon is this column. Problem is this column. Queen is this column. And you realize that evil's weightage, evil is there in other two rows itself. But here the weightage is more because it is repeated multiple number of times.
We need not to worry about how much weightage we have.
Right, it is calculating by
given that we cannot
right. It will calculate based on the number of times it is appearing, based on based on number of time it is appearing, based on how infrequently it is appearing in the other document.
That means in the multiple rows it will check, right?
Not entire corpus. Term frequency and inverse document frequency. What does it basically mean?
Like the review comments, let's say like somebody says like this is good. So you can also say not good. That just go by good.
Absolutely, absolutely. That means what he's talking about, the concept of bigrams. This is known as bigrams. I mean, here I'm choosing by default only one gram. Okay, 1 gram in only one word. Many times your combination of word also can give you different meanings. Right? Not good, not so pleasant. Right? Generally, max is 3. Okay, you cannot handle. Trigram is 3.
So what is inverse in TF?
See, term frequency is how much that word is appearing in that document. Inverse document frequency is how much times that word is appearing in other entire corpus. So it's the ratio. Right? A word is important if it is more frequently appearing in one document compared to the entire corpus. Right? This is inverse. So here, whatever he's saying, right, n-gram, so you can actually n-gram range. I think you can give it like this. You see, now the number of features increased, right? I gave n-gram range 1, 2, 3. And if I give feature columns, you will see these are the possibilities: evil, queen, evil. So these have three possible, three words at a time, isn't it? Understood?
So what do we make out from this?
What you make out is, if you see, what is the number of this? So let's take the first word, evil. Evil alone is okay. I mean, so you can see when evil appears, evil, queen, evil doesn't appear. Okay. So here, what are you getting is combination of words from this text, right? Evil, queen, like at max it is taking 3 words at a time, right? Queen, evil, continuous 3 words, right? If I write here, okay, I'll change evil by good. Sorry. So when people write so what it would mean is okay. You can see here, not good is one thing, right? Or not it removed.
No, we have given that
stop words.
Stop
Word is removed, so we can still pass that, to tell it that use not. Okay, but for simplicity, what will you do is,
Not is not a preposition article. It's an important word, right? To negate.
Yeah, it's using it, it's removing it. You see this not good here. Okay, when you see not good, okay, I don't know which number is it. And now it becomes very difficult to read, and that's why I was using smaller example. But you can understand not good is also has one weightage, right? I mean that's a thing. Understood, right? What is income? So we'll use it. Just keep all this information ready. We'll use it to do review analysis and all that. And you can understand that if you do not good and if you do bigrams, trigrams, your computation becomes very like this is very small amount of data which is getting this many numbers of columns, isn't it? Right. So if you that is why you have to take a balance between computation as well as accuracy, right? So generally 3 is the maximum number of votes, max. Beyond that. Understood? What is TF IDF? What is this guy? Yeah.
So you will put one data point to show that.
I'll use one. I'll do one. I'll just give you a few minutes. I'll just explain on classification. Okay, so that we can do some problems based on classification. Okay, so yesterday we understood what is regression. We didn't use any such classification, isn't it? Okay, let's understand. Logistic regression is similar to linear regression. Okay, just that linear regression is used for regression. Logistic regression, not what the name says, it is used for classification. Just that it is based on regression technique. So what do you do till this featureation technique is clear, right? So all these things will be more clear when I'll do a lot of review analysis, all those comment sentiment analysis and all those. It will make it clear. Okay, we'll use it actually. Okay, that will make it clear how to use it and all. Okay, let's first learn few more algorithms so that we can make use of these. So in logistic regression, basically what you do, you like for let's take a classification problem. Like for example, a tumor is malignant or benign, cancerous or not cancerous, right? So what you basically do, this is a tumor size, and if it is what you typically draw a line. Okay, you typically draw a possible line which can be a straight line or which can be a curvy line. So what is your end goal? Your end goal is to predict a line, okay, which will separate your data. That is why it is linearly separable, right? So what is the end goal of logistic regression? You have to predict a line. That's it. And data which is in the one side of the line is one class, another side of the line is another class. Okay, so we'll now see using by classification. Okay, so how do you represent your logistic regression? It's also this, right? H theta x is equal to right, that is what it is. H theta x is equal to theta 0 plus theta 1 x. Fine. If you have to predict a line, just for simplicity, a straight line, this will be the equation of the line. So for a particular x, what will be the output? Some value, right? What is our objective? Our objective is to convert this into 0 or 1, isn't it? If it is a by classification problem, right? Your logistic, what will be the output of logistic regression? It is h theta x theta 0 plus theta 1 x. Okay, so given the degree of polynomial, right? So this is simple or linear regression. What is the output of a given x? Suppose you pass tumor size here. What will be the output? Some number, right? But how from that number, how will you figure out whether it is cancerous or not cancerous? You want output in Boolean, isn't it? Right? Or you want output in class information, right? So what is applied? You apply something known as sigmoid after. Sigmoid is a function. This is a formula of sigmoid function. You don't have to apply it like this, but sigmoid means you're representing like this. If you pass sigmoid to any number, it will give you a value between 0 and 1. Understood? You pass sigmoid to any number, it will give you a value between 0 and 1. Yeah, logistic regression is used to do binary classification as well. When I can do for more than 2 class also. Binary classification means the output is of 2 classes. That is what is binary classification. Yes or no, right? Where is binary classification? If you have more than 2 classes, it is not binary classification. Okay, that is multinomial classification. Multiple classes are there. Okay.
The theta t is the transpose of that theta 0.
Okay, so that is just you don't. I mean, it is just matrix representation of linear regression. Whatever we did, if you try to derive it further, we'll get something like this theta t. So, what is logistic regression? Logistic regression means a logistic sigmoid function. After you calculate h theta x, you will be applying sigmoid to that. If you apply this equation 1 plus 1 divided by 1 plus e minus theta tx, that is e, you will always convert the number, whatever data you give, you will convert that between 0 and 1. Okay, and if you plot the graph, it would be like this. This is your sigmoid curve. Whatever number you give negative number, your separator is 0 here. You give negative number, it will you give number between 0.5 and 0. Your sigmoid is between 0.5 and 0, it will result into 0. You give number between 0.5 and 1, your result will be tends to 1, not close. Yeah, it tends to 1. So essentially, if you apply sigmoid function, remember this: you apply sigmoid function to a number, it will give you value between 0 and 1. Not full stop. Right? If it is value between 0 and 1, if it is between 0 and 0.5, it is a class. If the value is between 0 and 0.5, you say it belongs to this class. If the value is between 0.5 and this, it's the value of this class. That's it. Okay. Okay. Now understanding the cost function of logistic regression. Okay. Can you tell me what will be the cost function of logistic regression? Will it be same as your linear regression or not? Okay, output of sigmoid is cost function.
There it's like a linear regression, the cost function is a curve, and wherever the slope is 0, that is the linear cost. In this case,
so you have two possibilities here, right? In linear regression, you could have a benchmark that this is the right stuff, you compare with that. In this case, you have two possibilities, right? 0 and 1. I mean, whatever results you are getting it here, you have two possibilities, either this or this. Okay, so see this step. See this guy. So what is your h theta x? When you see this, h theta x is a prediction, right? And if y is equal to 1, that means the class to which it was identified is 1. Then you are directly doing it minus. So if you do log of h theta x, it is negative actually. To remove the negative, you are doing it. And you have to bring both of them in the same scale, isn't it? And the h theta x will be between 0 and 1. Right? You have to bring both of them in the same scale. To bring both of them in the same scale, what you can do 1 minus whatever is it, you will bring them in the same scale, isn't it? Yeah. So for example, you both of you are starting running. For you have to reach this point. I mean, you are at you have to do a 1 kilometer race. Both of you are standing at half kilometers. You ran towards 1, you ran towards 0. Right? We have to compare who reached first or how much distance who covered. Right? What I can do, whatever distance you covered, you went backwards, right? I can reduce it from 1 minus whatever distance your whatever distance is pending. That will give you the total distance that you have traveled. Right? Similarly, I mean, so that to bring, since you are doing, your objectives are different, but you have to bring them in same scale and compare. That is why we are doing a 1 minus h theta x here. right? Because you have multiple classes. Your output is either you are tending to this class, you are tending to this class, but both of them are right? It's not that one guy is right, one guy is wrong. Both of them are right. Okay, so you have to find the cost. Cost means how much are you far from your actual goal? How much far are you from 0, or how much far are you from 1? To do so, your internal 1 minus the h and theta x is there, and minus log of it will just bring it to the same scale. This is the cost function here. You don't have to do this by yourself, because here when you do logistic regression, when you do fit function, it is internally. So based on the cost value here, it will find the best coefficients for you, isn't it? That's it. That's it. Understood? Not understood? Huh? So see, you have two goals here. Just understand, huh? Two goals here. Okay, both of two destination. One I have to reach here, and I have to reach here. Both of them are competing, but you cannot measure their distance, right? Because somebody is reducing the distance from 0 to this guy. Somebody is increasing the distance. You want to bring both of them in same scale. So who is wherever this guy is there, right? Suppose he traveled 0.8. Okay, so to understand how much distance he traveled, what will I do? I'll reduce 1 minus whatever is, I'll basically compare with whatever is left here to bring them both on the same scale. That is what it is happening.
Okay, that's clear.
Understood, right? Okay, this is how you achieve that, bringing them both in the same scale and then comparing. That's it. That is your cost function.
Minimum cost.
You see this, the same whatever was discussed. So one guy is decreasing C, another guy is increasing. I have to bring them on same scale, right? Just do a minus of it. That's it. Once gradient descent has the value minimum cost, it can find for you the coefficients theta 0, theta 1, for which you're getting the minimum cost, right? Understood, right?
This is for 2 power.
If it is more than that, then you'll do cost function for all the cases, isn't it?
So 1 minus again.
So sigmoid output again have to feed it to the gradient.
Yeah. Okay, we don't have to do that. When you call fit function, it is automatically happening. Okay, let's ask. More than 3 also it will be, how you do it. What more than 3, I have the formula somewhere written. You basically do sigma of all of them actually.
Second it comes 1 minus, third it comes again 1 minus.
I'll show you. Third will be the which class number and output. I'll show it. This is what this sort of diagrams will see it, neural networks later on. See this sort of thing. That is the formula it becomes. You just be doing sum of all them.
So how do we arrive at this one?
Which one? This one, la? This one. This one would be. You see, this is actually easy. Okay, just.
How do we judge this is a formula?
No, I'll tell you how to get this. See, it is all inference, right? It's really easy actually. Okay, so now we understand how does two things work, right? So now suppose third thing comes into picture. What will you compare? You will compare that also with, wherever suppose you have this dimension and you have third guy who is moving in this direction. You also compare, right? How much is he pending, right? So all you have to do is in this case is sum all those things. That is the cost function. J theta is your cost function, right? You're just saying, okay, so how to put them on notation is a different game, but all you're doing is this K is the total number of classes, right? In earlier case, what was the total number of classes? Only 2, right? Now it has become 5, 10. So it is like sigma, sum of all the cost of all the classes also, right? See, mathematics parts, derivation parts is one side of the story, okay, but in like understanding it is not difficult. I mean, to use it, right? Now, I mean, it's very intuitive. Like if you are doing for two things, or you add more things, the cost will be more cumulative, right? Yeah. Okay, we'll see these things when you do neural networks later on. Fine. Understood logistic regression. Now we'll do a small exercise using logistic regression. And I mean, there is nothing to be surprised over here. It's saying fit function. Okay, before fit, you have to make sure data is in number format, right? Right. Fit. Then you have to make sure you are doing a predict. That's it.
So the graph you're showing was for S theta x species y, right? The graph you're showing for logistic was for S theta x species y.
S theta x is equal to
versus y, right?
Right.
You don't have a cost function versus this parameter graph for logistic.
Oh, this one is. This one, huh?
No.
Yeah. This one. This one is your
S theta versus y.
It's not really S theta versus y. So this is H theta. H theta ranges between 0 and 1.
That's what.
That's the information actually.
So cost function versus the parameter, we don't have it.
Cost function.
Or the cost function varies, then only we'll be able to get the minimum theta.
No, cost function is this, right? This is your cost function. Right. So cost function, I mean, so you can imagine, suppose you are at 2 theta, right? Theta 0, theta 1. So you will have a 3-dimensional matrix, right? Okay. And where theta 0 is equal to 1, theta 1 is equal to 2. So for that, these two values, what is the cost function will be kept over there, right? What you have to do, you have to find the minimum of this. That's what.
There is no graph for that. Because for the linear, we had a graph having j theta versus theta 0, theta 1.
The same thing is valid here also, right? Same graph, isn't it? You have what is your cost function? J theta is your cost. Theta theta is along the x-axis, right? Given the one dimension, right? So in this case also you have the same stuff. Okay. So therefore this is the curve. Okay. This is your j theta. Okay. This is your theta 1. Right, for different values of theta, this is the cost. You have to find again the same stuff, right? D by dx of this curve at this point. Nothing changes. The cost function calculation technique changes and nothing else changes. Your gradient descent will still work the same way. Which polynomial degree of logistic regression is giving you good result, you will still find the same way. You'll use polynomial, whatever polynomial features, right? And then we'll find a separator, right? All these things will still work the same way. Say well, I'm doing the same thing, but suppose this is the logistic regression. Okay, you have Okay. What you're doing, we are using iris data for classification. Iris data, right? This is your iris, 4 classes, four features, right? If you're doing iris target shape, it is 150 data, right? Then what you're doing, you're creating a linear regression model, a logistic regression model, just by this linear model dot logistic regression. Right? What will you do after this? You need to train the model, isn't it? You are passing first 145 data, right, in the training model. It is easily doable because data is in the rows of columns and present. The way data is represented is the rows of data, right? And this is the target information. I'm using first 141 among 150 data. I'm using first 145 for training and training the model. Last 5 I'll use for testing the model, right? So here you can see this is one of those untrained data. If you see, is the last data actually 5.93, 5.1, 1.8. Okay, this is, I haven't trained the model with this data. Okay, if I do this, I get this output. If I do this, I get this output that you see here. Okay, what do you see here? This is 3 classes. What it is telling you, what is the probability, what is the, you know, what is the percentage that, you know, this guy will belong to this class. So what you can see is the chances of this data belonging to class. How many classes are there in case of iris data? 3 classes. That is why 3. 0.001% chances that this belongs to class 1. 0.29% chance of this belongs to class 2. And 69% chance of this belong to class 3. So what will be the outcome? The sum of these things will be 1. Then what will be the outcome? Outcome will be that this guy belongs to class C, which is correct actually. Right? Of course, if you are doing like this, you can directly do this.
Yeah, actually, this is what confused me.
What?
Here, the sum of the rows you said it should be. In the even case we may.
Yeah. So no. There is the weight. How important is that word in that text, and that is measured in the scale of 0 and 1. From that word, here you're telling that, you know, chances of this guy belongs to this class is this much, chances of this guy belongs to this class is this much, chances of this guy belongs to this class. Okay, that's how. So if you do this, is predict probability, will give you all the probability details. If you don't want that, if you simply want the result, you do like this, predict. Understood, right? Now you guys do one small exercise first. Okay, there is a wine data set. Not wine. What was the data set? Go open this website. I want you guys to do. Okay, maybe a little later. Let me do one more exercise. Okay. After that, around 11:30. Okay, I'll give some assignment. Okay, you can try it over here. Okay, for half an hour. Or you can use the labs also. Okay, this part is clear. Simple logistic, using one logistic regression to solve this problem. Okay, so we can see algorithm is one place, feature conversion is one place, finding the algorithm is another thing. You understood the entire ecosystem here now, right? So what is the thing that we learn now? We learn now some more algorithms. So that we can, some more algorithms can compete with each other, find the better techniques, right? Then later on, and as the course advances, we learn some boosting techniques also. Okay, so what is boosting techniques? That is like, you know, if your normal algorithm is 95%, it will give you 100%. Some boosting techniques actually. Okay, those are in competitions, people use this to, you know, gain what do you say, momentum, what is it, better marks, better accuracy. Okay, these are if I use the scikit-learn boosting techniques. Okay, anyway, we'll reach there. Okay. Okay, now let's see one more classification technique so that we can compete among each other. Okay, that one is known as name-based classifier. Naive-based classifier. Naive-based is classifier based on Bayesian theory. Bayesian was was a very famous scientist, and in people who had statistics in their masters or in their graduation, they must have seen a separate book on Bayesian actually. Okay, you can find books on just Bayesian theory. Okay, so what is this algorithm? This algorithm uses Bayesian theory, of course. So understanding Bayesian theory is out of scope of syllabus. Okay, but what we'll understand how to use it. Okay, what is the fundamental maths behind it? Now, what is Bayesian theory basically? Okay, it is used in this is the next type of classification. One is logistic regression that you have seen, and the next one is Bayesian naive-based classifier. That's what you call it. Okay, what happens in naive-based classifier basically? Okay, let's correlate with your email. How many of you? What is the number of spam mails in your mail? How much? Give me some rough numbers. I mean, 100 mails, or say, how many spam mail do you get generally?
Per day?
Not per day, as of now. Huh? Total you get 400 or you mark?
20,000.
Huh? Depends how many, wherever you are using that website. You are using? Gmail. How many 100 mails do you have?
So far, 50, 60.
That's it. Okay.
6,000.
I'm seeing if anybody can beat me.
10,000.
Huh? I have some 60,000, I guess. And then the reason behind it. The reason behind it, I have not trained the machine learning model in my mail to behave accordingly. Okay, this is obvious. Not this one.
The more website you go, the more chance of you getting spam.
Yeah, and that is email ID that I've been using like 15 years for sure. Okay. Yeah, 56,000, pretty close to that. Okay, the why is it so? Okay, enough. Why is it so? Basically, I have never marked a lot of mails as marked as spam unless that is very much irritating. As long as BI and LIC people are sending, that's okay. If there is something apart from that which doesn't give a good picture, I will definitely mark it as spam. But I don't do this active marking spam. People who are getting lesser mails and you do mark spam, or you don't use that email book. Huh? You unsubscribe itself. That's a different game. So people who continuously mark their mail as spam, what do? You right click on the mail and move to spam, something like that. That's what you do, right? So just by seeing the spam, the machine learning model in your mailbox, everybody has a different. It's not one machine learning model for everybody. Everybody has a different machine learning model. You have, so whatever is spam for me may not be spam for you. Okay, right? So everybody has a different thing there. So when you mark a mail as spam, what happens internally? Something happens. That is what naive-based algorithm gets applied. What does it do? Okay, it sees all the words that is there in that spam mail. Okay, finds out the probability. It is not probabilistic game now. Finds out the probability of a mail being spam. Okay, I mean, it finds out what is the probability of this word in a mail, this word to be present in a spam mail.
But also, sender?
Huh?
Does it consider sender also? Sender's name?
Sender's name, it might, I don't know. It might. Most likely no. But it definitely uses the text information, like things like free, or things like deposit, or I don't know. I mean, there are a lot of such words. Sale, free, coupon, right? Whatever. There are some words, right? Okay, which may not be suited for public use. So these words, okay, what it does, it tries calculating inside some numbers corresponding to each word, that if this word is appearing, what are the chances of that mail becoming a spam. Every time you're marking a mail as spam, then what happens when a new mail appears with whatever words it has learned as spam, right? It will try to do some cumulative addition sort of a thing, sum of probabilities. I'll show the equation, sum of probabilities. Just understand this, sum of probabilities it is doing, and finding the end probability of your mail becoming spam.
And in Microsoft, we create a rule, right? So that is core logic kind of a thing.
That
so
is.
This is
machine learning. That is rule based filtering. That is this guy, machine learning based filtering. So it tries to find out what is the probability based on probability of each word. Whenever you're getting a mail, it tries to find out what is the probability of this mail becoming a spam. Okay. What happened?
Share it.
I didn't see anything.
Okay.
Okay.
It's like for every user, one model will run.
And
based on the input time you get, right?
Course of mail.
So be thankful to people who did that. Yeah, that's what it is. Because
spam that much.
of course, not spam. Spam is a big problem, right? Yeah, I mean that is how it is.
And they're giving free of cost.
Huh?
They're giving free of cost.
No.
But they also send our details to.
Yeah, so that is the plus point. I mean, nothing comes free in this world, right? So they knows everything what you do.
Storage space maybe.
Yeah, but at the cost of your information, they know everything about you. Everything.
So
Okay.
what did last
If you go back to your college days email, sometimes you say, oh shit, I did that. Okay, so they have all the information. Okay, the thing is there are a lot of privacy contract and all that. That's why it's fine. But they have. I mean, that's why all the learning comes from there. All the machine learning that happens, right? It's coming. You can see in your email, right? The advertisement there. Go sale based on the tickets you have purchased. It's people are making a lot of money, definitely though. Okay.
Even with Amazon, it will suggest like if you buy one course, it will suggest that same author, same topic. YouTube also.
Right. So that is how it is, and understood, right? What is happening in naive Bayes basically. Okay. Now the formula of naive Bayes is, see, this part you understood. I'm given a particular message. I mean, word when it comes, it tries to find out what is the probability of this word becoming probability of this word. If this is present in a mail, what is the chances of that mail becoming a spam? Then you combine all those probabilities. Then you get a cumulative result. So whenever a mail arrives, it finds the probability. If it is above some 90% or something like that, it then marks that mail as spam. Clear?
The classification is spam or not.
Spam or not. Of course, you can have much more classification. I will see that. Like we'll go like document classification is there. Can you see my code? Suppose this is so you can see these many type of documents are there. Can you see this? This many type of documents are there. Okay, you have to identify based on the text which document does it belong to. Understood? This is what Google News does, right? Based on the content of the text, it will find you what is the category of the document. Right? This is used in whenever you are writing, reviews, comment, raising tickets. Based on the ticket content, tickets, right?
Yes.
Customer tickets.
Yes.
Based on the ticket content, you identify which team should handle this. Is it a bus delay issue, or is it a refund issue, or which issue is this? All this algorithm that's applied.
Last week there was an article in Facebook. People chat, and if somebody says, I want to buy a new car, and searching for a new car, this color, this, and then Facebook, after 2-3 days, Facebook post customized ads for that person, like about card discounts.
I haven't seen that. Yeah,
That
possible.
became an issue, I think, and now they stopped.
Yeah, because that is a.
Because somewhere excited, like how come I'm getting the ads?
Okay. I'm not aware of this.
Some people request, oh, I'm buying a car, how come I'm getting these ads? So
So
my
that happens
information is not very secure. And
If you keep your Facebook open and search Amazon some things, it automatically comes in Facebook.
The ads and all that is come. That's a different story, but I don't know chat
customized
thing.
ads.
No, that is there, but
That is bot, it seems like a backend they're running about.
that is there, but I'm not sure if the chat information is used. They might be doing some Google search and all that.
Chat information, it became an issue.
Okay. That sounds interesting. Yeah, Sunil, you were trying to say something?
I have a question. Thing is that let's assume that I have two options. Option one is that rule-based classification, right? I have certain rules to classify given data. Second thing is that algorithm, what we have been discussing. So given an option, which one I should be using to classify the data, the rule-based or algorithm-based, because rule-based is very easy to approach and very easy to solve. The algorithm, there is a lot of trial and error effort, right? So just curious to know your opinion on that.
Okay. You just give me 1 minute. Hello.
No, I'm not getting what it is.
Yeah, as far as rule-based is concerned, right? Rule-based things are never scalable. See, when you do, if you use Microsoft Outlook, yeah. So you write rules there, filters rules there, and all that, right? So that is one approach, right? Where it is fine for smaller stuffs and all that, okay. But it doesn't scale well. You have to always write some new things comes into play. You have to keep adding some more and more rules, right? On the other hand, if it is learning based, right? So it scales very well. Like Gmail, if you are using 10 years for 10-15 years of Gmail and giving it everywhere and you maintain proper rules and all, it will keep on learning, so it will keep on growing. So of course, rule based is definitely simple and easy if you have simple ecosystem, but that's not the case nowadays. So learning based stuff can grow.
Yeah, because but the one thing I agree on the advantages on this machine learning or data science or anything. The thing is that here for any new data, right, we need to train that net or neural net or the system, right, or algorithm, train the algorithm to recognize and classify the new set of data, right? Am I right?
Right.
Otherwise,
right. That would be as simple as marking it as spam, something like that. Okay, that's it. Okay. Yeah, I understood your question. But training would be, whenever you are marking something to spam, what is happening? You are typically, training the model.
Okay. But this logic you have to build in background, right?
Background generally, that is a application logic, right? I mean, that is where they will struggle and write a bed code for you, so that for user, you don't have to add any rules. I don't add any rules here, but apparently, a lot of my mail goes to
now
spam.
You are building the application, right? So for that, the perspective is asking.
From building application, definitely building an application with learning in it will be a difficult task. Okay, but what is the, how do you solve for
my question was about the same thing actually. What Avantik is explaining, that actually, for example, you have built an application that is actually the rule based, and whenever the new requirement comes, there's a big top down or bottom up approach need to be done, right, to address or accommodate particular requirement. But when the neural net, the machine learning, the procedure, the thing is that we need to create a data to train the net, then process the data, classify the data, right? That's I don't think we see that here. Yeah.
Right. Okay, so if you're planning scalable stuff, learning is the way to.
Yes,
right?
yes.
And see, whenever you're developing something, right? I mean, you don't, when you're developing a product, you want the complexity for developers. You want to make customers' life easy.
Yes.
That is how, every product turns out. You want to bring all the complexity to developers. Let their life be a good case. But customer experience should be seamless. Right? So that is that's why you bring all the complex tasks towards developer. This guy gets it. Okay. Let's move on. Okay, so that is fundamental philosophy of classification. Now let's do one case to see how to use it, how to do this.
So before that, actually, what I understood, that whatever the parameter, the weights or bias generated for this particular data, it is actually the module parameters, right? It's called as module parameter.
Model parameters, right?
Model parameters, yeah. Derived from the model.
Right. I didn't get your question actually.
No, just want to clarify on that actually. Yeah, it's correct.
Yeah. Okay.
Last class we discussed about hyperparameter and the model.
Right. Okay. Let's see here. We'll learn few more concepts. I mean, see, what I'm trying to do is I'm adding one algorithm. Like in this case, using now we'll learn what is your confusion matrix. Okay, so that we can continue learning algorithm as well as more things around it. Okay, let's see. So this is inbuilt data set.
The formula for the name is.
I'll come to that. Okay, just let me show how it works first. Then I'll go and show that's nothing but sum of probabilities. Okay, I'll show that. First, this is what you are doing. You're trying to load something, load data, which is a load inbuilt data from scikit. Okay, you can see 20 news groups. These are like MIT new email data actually. 20 years back, MIT email data of different groups. Right. If you do this, right, it is creating this 20 news groups. Then these are the possible classes. 20 classes. Fine.
Yes.
Okay. If you want to see the data will be this is all the data in it. Oh, sorry. This is a list of stuff actually. You just do length of this. Okay, some 11,314 mails are there. Okay, and total number of targets is this 20 targets. Okay, now what you want to do among those data, you want to break. I mean, these are all inbuilt functions here. You want to get trained data and test it out of it. Understood, right? And what are the categories you are interested in? You are interested in, say, all the categories in this case. Okay. Basically, I don't want all the categories because it will take a lot of time to train the model. Say I want to use only this much. Okay, so you have this guy. Then you have train data, right? Test data. Test data is this guy. Fine, right? Okay, you are only taking these categories.
How to get this? How do you see the ratio rate constant?
This is all inbuilt actually, just for the sake of convenience of getting the data. It's all inbuilt. Just that it's all text data here. You want to see how does one text look like? It looks like this. Train data, right? You just do like this. Train. Okay, you can see this is the text. Right, we can see Polytechnic Institute, some information and all that. Some text, some text. We want to find out which class category does it belong to really, or we'll give our own text. We'll try to find which category does it belong. For that, first we're using a TF vectorizer, right? Okay, then we are creating empty stuff. Then we are training the. This might take some time because this is doing a fit transform. Okay, since there are a lot of words in it, so you want to see the shape of it. Some 5,361 rows because this is the number of data, and how much columns of data is present. It is some 60,000 columns. Okay, now let's get rid of some useless words, stop words. You can see number of columns got reduced, right?
Yeah.
But that even that's too much. Okay, 60,000 columns is some huge amount of data. Then what is the model you are trying to use? Multinomial NB. Sorry, Gaussian NB. Gaussian NB, right? Okay, so this is the model that got created here. That is basically I have right somewhere.
Didn't import it.
Yeah, now it imported. Okay. Now, what do you want to do? You want to train the model, isn't it? With target information. This is your data. TF is your model data, right? Yeah. And this is your target. Let's see. But dense matrix is required. So use 2-array to convert this into dense array. Understood? There is a sparse matrix generated. But remember, it will take some time now. Okay, it will take some sweet time. So after data.target found input variables inconsistent number of samples. Achha, let me check. Oh, that is, I've given data.target, right? It should be, where is data tf.target, I guess.
Right.
This is train.data, right? So yeah, I should give it train.target, isn't it?
Yeah, train.target. Yes, we are training it.
Train.target. Okay, remember we are talking about some 59,000 columns without optimization. Okay. Almost choked. This one. Gaussian NB is nebis. Gaussian nebis. Okay, so you have multinomial NB and all. Somewhat stuck. Okay.
So,
ये कोई चीज़ नहीं
could not respond. RAM. ఎక్కడ అది పైన
Even there is mega model. This is an old model. Even there is a this one. This one more way of the quality 460. It's like light. But comes in the range of this is I'm not sure. Like I have to look at all
Exactly. We'll tell you, we'll take 15 minutes.
Sorry. He'll be here. Lucky.
Just one question.
Yeah, Sunil, hello.
Hey, Avanti.
Yeah. So yeah, now the training is done.
Just one question. Just to remember that.
Everybody took a break, so 5 minutes will start. Huh? Should everybody went for break?
Just to remember.
Hmm.
Probabilities are like sum of probabilities will be this, right? The other thing is, you know, what you're doing is you're scaling the content. That means you're finding importance of that word in 0 to 1. That is not probability.
That can occur in any.
So now,
only for cost kind of things, it will be sum of.
Only for cost kind of things?
It will be sum of.
Right. Probability actually.
The demand for AI is going up because they started using it in mobile digital appliances.
They will start actually. They okay. So what we have here is we are choosing the number of features, number of you know, classes that we are interested into, training the model. After this, only one thing changes over here. We are making a pipeline here. Okay. First in the pipeline, the one transformer is this guy, stopwords English. Right. And after that, you are doing a multinomial NB. What is multinomial NB? It's a type of name-based classifier. Multinomial NB is good for, the comment is also written there, it's good for multi-class classifications.
Okay. This is like
suppose in this case, what you have to do, you have to identify among 4 classes which one is best for you, right? So now using multinomial NB, you will be able to do that.
What classes?
More classes. In this case, what are the varieties of classes you have? You have graphics for sales space, decision, miscellaneous. Right. So whenever you see multiple class, multinomial NB is good. It is a variation of your regular name base. So now you see here what you're doing. You're just creating a pipeline here, isn't it? See, one transformer, one executor. After that, what do? To train the data, you will pass data train.data.
I just have one basic question. The name base, give an example of this. Right? So in supervised classification,
In supervised classification?
Supervised classification. So classification comes out is an example for parameter.
Yeah, classification, there are various types. In classification, we have name base one. Name base has multiple variety. Gaussian name base, multinomial name base. Okay. Another one we have seen is logistic regression in classification. Understood, right? So these are variety. Okay. Now after that,
so what's the difference? Logistic is 0, 1.
Logistic regression is for logistic regression is logistic regression can also be for multiple class. We used it, Sentosa, Virginica, versicular.
Yes.
Right? Three.
Right. What is the difference?
There's no, see, difference is I mean, there are different algorithms. Some is good for one thing, some is good for another thing.
So this is good for
multiple classes.
Logistic is good for only 0.
No. It can do that stuff. Okay, the thing is, logistic, see, this name base is good for where there is a lot of text involved, probability involved, sort of email categorization. This is good for logistic regression is good for where you have basically linearly separable data. Okay, so just keep these algorithms in mind. Okay, so of course we are not in a stage where you can really say which one is good for what. Okay, so how and name base is good for when the data is too much of data and not less complex. It is good for that. Okay, and what are you doing this? After this, you are doing a model.fit. This is the training data, this is the test data.
Yes.
Oh, I have a class too. What happened? Okay, quickly, let's do it. If you want to practice, you can use this case and give some assignments. You guys can work together. Okay, let me quickly finish this. Okay, so somebody can take responsibility of getting a flask. Okay, okay, let's quickly do it. See, yeah. So what are you doing here? There are two type of transformer that we have. Okay, see the thing. One is TF-IDA vectorizer, one is count vectorizer. Right? What you are doing here, we are creating a pipeline here. Right? We are creating a pipeline. One pipeline is for the pipeline consists of a TF-IDA vectorizer, right, for transforming string into numbers. The other guy is your multinomial NB. Right? And that is what you are doing here. Your pipeline is created. After the pipeline is created, you can fit it, isn't it? With the data. Text data, isn't it? Your train.data is a text data, right? And train.target is your target information, and you have the model ready. After that, if you have to predict, all you have to pass it like the model predict love all games. It is giving you class 1, right? After that, you can give me any string. It will find you which class does it belong to. Okay, after the class, you have to execute this code. Okay, which class does it belong to? This is new 23 name base. Then understood, right? So far, so you give it any text. Be it as of now, it might be trained to that. So here I can mention. Okay, this is the training part.
And test also we have.
Okay, so this is the prediction part, right? Now here. Suppose you God save us. It is giving you class 3. Let's see what does class 3 means. 1, 2, 3 Christian. See, this text I don't know if it was there or not. I just gave random text. It is able to identify that it may belongs to here. So if you write
something God for sale.
God for sale.
God for sale. So where it will classify.
So that is where your TF idea comes into picture, right? Whose weightage is more, God or sale? One, unfortunately, sale is more. Sale is more. Sale is I'll go based on the training that has happened. I realize sale is important more than God. Okay, understood, right?
Taking real time.
That is right. Okay, now you have to find how good is this algorithm, whatever we did now, right? We have the testing data anyway, right? So for this, we'll use something known as confusion matrix and accuracy score. Okay, so what are you doing here? This is a stuff. You are doing a confusion matrix for test or target and labels. This labels that you see is for test data, right? See, when I do this predict test data, what are you getting? Getting the labels. Labels means the class to which it belongs. 0 belongs to class. 0 belongs to this class. Understood what is labels, right?
Yes.
These are your
classes.
Actually. These are the classes, right? So this is class label 0. This is label 1. This is label 2. This is label 3. This is label 4.
What are we trying to do?
A confusion matrix. What you are trying to do is we want to identify how much misclassification is happening. The data actually belongs to this class, but accidentally you are doing it. It is getting to the other class. So that is what you are doing here. Last topic, I'll revisit this in the next session. So what you are doing here in the confusion matrix, you are giving the test target, the actual value, and the prediction. Right. Right. Now, if I dump the data, it becomes like this. So what does it mean? The middle one means this is the actual classification that happened. Okay, the middle ones. The other value, that means it is class 0 and it was identified as class 0. Okay, if I have to, I'll explain it next time how is it coming in this way in the graphical format. Okay, just see the thing. this graph, graphics data. This is the true level. True level means what is the actual level of it, and this is the prediction level. Computer. So 360 true level is classified as 360 correctly. 10 graphics is corrected as Christian. These are misclassification. Understood, right? Now how to read this matrix? Okay, so this one along the diagonal will be the correct classes. Things here and there will be the misclassification. Here, okay, use this code to do this thing. You get into you use I think GitHub has the review data. Let me check now. No. Okay, so go here, search for Amazon Fine Food reviews. Okay, so I'm texting it to everybody.
What is a k-means cluster or something?
Huh?
What is K?
This is actually I'm just sending in chat to everybody. Please note down because after the session ends, it will be gone. Amazon Fine Food reviews. Okay, so what you have to do? It has food review. So now there's a review comments. You have to identify which class it belongs to. Okay, if you are yeah, you can use the project 7 as a reference. You can use project 7 as a reference. Okay, try to do it. Okay, and first execute name based that one, then use multinomial here and try to do it. Okay, multinomial name based for multiple classes. Okay, you can use that space, common space. Just check. If you want to practice it here, if you want to go home and practice, that works. Okay, I'll end the class. Okay, taking another class. I mean, this class was meant for 11:30. Okay, so do the revision and try practicing from this guy. This is there, right? The assignments. You know where is the assignments? One sort of assignments is given here. Machine learning assignments. Few of them. Okay, you can click here. Machine learning problems and ML problems. This one. Amazon food reviews. Yeah. This is the one. Okay. Try to do with it name base and logistic regression. Which class does it belong? Okay. Okay. Use the references coded 23 is the file that I was using now. I'm stopping the recording. Use that as a reference code and